Hello and welcome to yet another video from our series focused on improving the state of the software development industry called Raise the Bar. I'm Bolboaca and I'm coming to you from the Mozaic Works studios, and today I have a question for you instead of answers. And the question is, can we trust third-party libraries? At the time when I'm recording this video, many developers are scrambling to fix issues related to the security vulnerability that was introduced in Log4j2 that was recently discovered. And I'm not going to go into the details of the actual security issue. I'm sure there are many materials on this. Fundamentally, it's about an injection attack. You can pass in some data, for example, through the browser name that you pass through the HTTP request that you are sending, and under certain conditions, this can be interpreted as a URL and point to an external resource, which would download some kind of file, and then you would be able to execute remote code. So fundamentally, it's an injection issue. A potential attacker can inject some URL with the purpose of doing something nefarious. What I'm more interested in is the things that this shows about our industry. We have a ton of software development projects that are using hundreds, if not thousands, of libraries, of third-party libraries. I guess the weirdest one today for me is JavaScript, where you have a bunch of very small libraries that you're just downloading. Every time you install Node.js, you are downloading hundreds, if not thousands, of libraries. And this is just to start a project. If you add things like React and some plugins for React, or Angular and some plugins for Angular, or Vue.js, suddenly you add a bunch more plugins, a bunch more third-party libraries. And how do we know these libraries are actually trustworthy? This is a big problem, because if you have a large project which depends on smaller projects, and those smaller projects are not fully tested, not maintained, some of them are open source, and of course they are maintained to the level at which an open source system can provide. Developers need to eat, so of course people don't work for free. They work because they want to solve a problem initially, and they create an open source library to solve that problem. But then when you need to take this into a professional realm, you need to ensure that these things are tested properly. And sometimes the initiator and the maintainers of these projects don't have the necessary time, don't have enough money, cannot hire people, or there are not enough people involved, or there's all kinds of issues which are perfectly understandable. This is not a reason to blame open source developers or to say that open source doesn't work. Open source libraries bring a lot of value for us, and I think we need to recognize that maintainers of open source libraries can be can put a lot of time into this, and we should appreciate that, even occasionally, if not often, with money. But beyond this, there's a problem with dependencies in software development. We are depending on libraries, which are depending on libraries, which are depending on libraries. And this chain goes deeper and deeper, and you end up with a whole lot of dependencies that are not completely tested all the time. If something at the bottom of this pyramid is not fully tested, then the whole thing can collapse because we've forgotten some kind of uh, verification in the code. So what is a good solution for this? I guess what enterprises have done until now is to review the code and to involve people from their own organizations into maintaining the projects that enterprise software depends upon. And this is one of the models that was used until now. I mean, I'm not a specialist in this area. Perhaps it works, perhaps it doesn't. But one thing that I know is that we have tools to deal with these kinds of issues. And those tools are automated tests and static code analysis and well, different types of automated tests written by different types of specialists. So imagine, for example, that instead of trusting a library just because it's there and just because it's used by many people, you would be able to trust it based on a very good automated test suite. And that test suite would include security tests. I mean, an injection test is not that difficult to do, no matter how many things are involved there. I mean, you just need to play around with inputs and try to brainstorm possible strings that can be introduced there. And even if you don't think about those things, there's another way. You can use string generators to create automatically various types of strings, including URLs, including dates, including names, with various types of encoding, with various types of special characters, with all kinds of signs inside, and so on. And you can go with these types of patterns and use random string generators combined with automated tests. So you could, for example, on one hand have your automated test that prove that the library works based on what you want, on how you want it to work. But on the other hand, you could have tests written by security experts who try to actively include injection or attack through injection. And if those tests pass and nothing happens, then great. And you could also have on a third level tests that are based on random strings or random numbers, and whenever these tests fail, you just save the strings that have and the values that have produced the failures. So this would be a much better way of dealing with third-party libraries. After all, when you get anything else into a system, so for example, when you change the wheels in your car, you can be fairly certain that those wheels have been tested, have been checked, and they work on their own level. But in software, we don't have this because we keep staying away from proper automated testing of everything. Now I'm not sure if this is the case of log4j2. Perhaps it had some tests, perhaps it had limited or not enough tests, perhaps it didn't have these types of security tests. But I'm not sure, but I think in general the problem is we need to start building more trust into the third-party libraries that we are using. And by third party, I mean here any library that you are pulling that is outside your control. It can be from the same organization, but from another part of the organization, from another team, or from another group, from another department. So why don't we have this yet? Of course, it's not easy to write these tests. You need to know a little bit more about security. But these types of attacks have been for a very long time have been around, and injection is something that we should reasonably expect as a possible attack. Injection by introducing URLs also, it's not unheard of. It's weirder perhaps to test things like injection through images or injection through handcrafted script code or handcrafted assembler code or something like that. Okay, I can understand that. That's more difficult. But things like injecting a string, why don't we yet have test suites that check for that? So look into your language, find out how to build generators. You can do that nowadays in Java, you can do it in C++, you can do it in Groovy if you cannot find an easy way to do in Java. In Groovy it's much nicer for JVM. You can do it in Python, you can do it in JavaScript, you can do this in almost any language that has the concept of, well, some functional programming concepts introduced in the code, because it's easier to do this with things like actual generators than with something else. You also have resources on the internet on how to do this. You can generate strings automatically on various websites and try them out. So I think we should go further with our tests. We keep thinking of our unit tests as either something that we have to write because somebody asks us to, or as something that we write to ensure that our code is working properly, or just to drive our code to where it works and just write a minimum amount of tests to make things work. But I believe we need to go further. We need to add more edge cases to our unit tests. We need to add security issues to our unit tests. We need to add generators to our unit tests to ensure that we find these weird issues that happen. And do this, combine this with things like automated static code analysis of various levels, and you might get at the point where you find these types of issues before they affect millions of people, because this is what has happened now. So once again, please don't take this as a criticism for the log4j2. I haven't studied their code base. I don't know what they've done, but let's look in general on how we can raise the bar on these issues. I think we can do better. So if you have any ideas, comments, thoughts about what I've been talking here, if you'd like to learn more about these techniques for writing tests and how and what should you be careful at when you write security tests, please let us know through comments or through social media or by writing emails to us by contacting us on mosaicworks.com. Thank you so much for listening, and until next time, remember to think, design, and work smart.